So while we wait for a few more candidates, a few more students and scholars to join in, maybe it will be a good time to get introduced to the team that is already here. I understand that not all of you are from the department, coming in from diverse backgrounds, and it would help to perhaps understand a little bit of where you are coming from and where your perspectives lie. So we can address some of those questions, some of those perspectives in our discussion.
Yeah, hello. Yeah, we can start. So I will ask Shubhodip to initiate the session of today's webinar series.
Okay, ma'am. So can we just start the recording?
I have already started.
Okay, okay. Thank you, ma'am. Thank you, ma'am. Good evening, everyone. I, Shubhodip Chandra, Assistant Professor of B.V. Poddar Institute of Management and Technology, welcome you all on behalf of the organizing committee of Department of Information Technology on the last day of 6 days webinar series on transformational technologies in recent days, TTRD 2021. We are honored to have our today's speaker, Mr. Atanu Roy Chowdhury, founder of Capsule Labs. I'd like to take the privilege to introduce the speaker, Mr. Atanu Roy Chowdhury. Mr. Roy Chowdhury is an IoT evangelist and founder of Capsule Labs. He is a technology mentor of Ranmir Foundation, which focuses on bottom of the pyramid innovations across 7 states. He was a techno-functional consultant for IoT AI-led digital transformations, providing delivery of and solutioning support to LTX Global Sales Team. Prior to LTX, Mr. Roy Chowdhury was a member of technical staff at Infosys Set Labs, Harvard Sensor Networking Labs, Telcordia Advanced Technology Solution Labs, which is now Ericsson, and Blue Highway, Welch Allyn Company. He has passed postgraduate degrees in computer science from IIT Guwahati and Harvard University, and he is a senior member of IEEE and Computer Society of India. He has published over 35 papers and patents in the area of IoT and wireless sensor networks, and provided consultations for over 100 IoT-based solutions globally. Sir, over to you for your deliberation.
Hello. Thank you, Shubhodip, for that warm introduction.
You're welcome, sir.
A very, very good afternoon, early evening, late afternoon to everybody who's joined in. So today the way I see the audience today, I see a lot more senior people around. So I'm going to structure the talk a little differently. Originally, I wanted to make this presentation about the career opportunities that are there in IoT. Instead, what I'll do is I'll try and address a little bit more about one particular area which is very much more relevant for information technology professionals, and we will look at how the paradigm of IoT really brings about a monumental change in the way the applications are built and the kind of new workflows that are becoming prevalent. Right. I hope that this will help you take forward much more interesting, much more relevant projects to your students. It will help you to spread the word about what is coming up as the next generation of solutions, and we hope to see the next generation of solutions coming out of that. The way this particular talk is structured, for those of you who are students, I am going to post a link for a certificate of participation. Right. For those of you who are not students, you are always free to post in your responses, or my contact information is also shared. So if you wanted to get in touch for anything whatsoever, I'll be more than happy to entertain your questions. Right. So the way I'm structuring this talk today, I really wanted to talk about three things, three basic or three broad areas. So one is around the applications that are coming up in IoT. I already saw that there was already a presentation by one of the previous speakers on the use of IoT in healthcare, and coming from a background in healthcare services with Blue Highway and Well which Well itself is a 120-year-old frontline diagnostics equipment company. We'll talk a little bit about those applications, what are the technology mega trends, and the kind of application workflows which are new for IoT. And the third section, which may or may not be relevant to this audience, is around the market opportunities that are developing in this space, right? That said, I find it very hard to kind of quantify what exactly is IoT, because in my mind it is a paradigm. Right? It is the paradigm of being able to collect information from hetero unknown places, from systems which were previously unconnected, looking into that data in the context of other things that are happening around it, and being able to deduce meaningful information, meaningful knowledge, meaningful wisdom out of those correlations. Right. So that is what IoT as a paradigm is in my mind, and but this is something that did not quite come about in a single day. We had to start at a very fundamental level and kind of come up to this scale over the last almost 40-45 years, right? In this journey, what I want to start off with is by probably saying that, if you look at the late 1980s, you had the age of personal computing coming into its own, and with personal computing, you had a computing device that was available for an individual, right? So their context, their when I say context, it is in broader term that I want to use it, rather than just their login credentials, their documents, and all of that. It's the replication of somebody's work, somebody's experiences, all of them getting captured into a device. Right. That is what things were in the late 90s with the advent of the computing, or the personal computer. Right. In a few years' time, by the mid 1990s, the laptops had come into the market, and with laptops, there was again a change, because the computing infrastructure had its own independent power supply, which meant that you could take the laptop along with you, which meant that your context and your data could travel with you. This made a huge amount of difference to corporate personnel who are traveling around with a lot of sales and business data. It made a lot of difference to field engineers who had access to their readings and all of their scientific data on the go. It made a lot of difference to the scientific community itself, right? You could collect that field data. So overall, the ability to, just by the simple act of being able to have a system with its own power, a portable system with its own power, made a fundamental change in the way we started thinking about computing. It wasn't a device that you brought and plugged into the wall, but it was now a device that could carry, that could go along with you. By 2000, another major evolution had started, and cell phones were starting to come into the market, not large bulky devices, but really portable devices that could be carried on your person. With these, as the technology for the cell phones developed, they were not only powered, but they now had communication capability along with them. right? With the laptops, you had Ethernet and you had to plug it into a wall socket, but with the phone, you were starting to become really free. And this led to a lot of new innovations, including pay by phone, including IVR systems and the like. But now we already see that most people were starting to get not only a laptop, but not only a desktop, but a laptop as well as a mobile phone. So communication became a major component of these devices, right? And with the adoption of mobile phones, pretty soon you had almost a billion phones that were all around us, and phones started surpassing the number of laptops, and laptops started surpassing the number of desktops that were available. Fast forward another 5 years into 2005, the reason for logging on to the internet started to change, right? And because of which the internet kind of expanded. And why it expanded, I mean, one of the major attributes of that was because social media was on the rise. In 2000, still the internet was largely dominated by the research community, where they were looking around for a few papers here and there. It was dominated by the e-commerce, with large e-commerce platforms, e-commerce companies which were trying to sell various things on the internet. But by 2005, majority of internet traffic was being driven by the need for accessing social media. And now suddenly this interconnection of humans, interconnection of contexts between humans, that became a major driver for logging on to the internet. I am getting onto the internet because I want to see what my friends are doing. My friends are getting onto the internet because they want to see what I am doing. And this started to lead, they started getting a critical mass, after which it became self-sustaining, right? And people were using the mobile communication platforms, the cell phones and the laptops to access more and more of the social media, right? So by 2010, Apple had already introduced its, the first generation and the second generation of its iPhone series, and the phone, the entire screen of the phone suddenly became the internet. Right? It became a way to get into the internet. With the advent of social media and advancements in communication, these smartphones started replacing a lot of the traditional workflows that we used to do, on the laptop. And from 2010 onwards, more and more access to the internet was being driven by these mobile devices, leading to the development of a whole new set of chipsets which were designed for low power computation as well as inbuilt communication. Right. These mobile phones started coming with different connectivity options. They had Wi-Fi connect. They started having dual connectivity with the mobile backend, as well as with the Wi-Fi systems, as well as with Bluetooth systems. There were a number of different different communications. NFC started becoming popular. So quite a few connectivity technologies. The mobile phone started becoming gaming platforms. So they started building in a lot of sensors in them. There were proximity sensors to figure out if somebody is holding the phone near their ear. There were accelerometers, gyroscopes, pressure barometers. So there was a whole lot of sensing infrastructure that was started to go into the phones as well. Plus, the mobile, that little 6-inch screen became a gateway for connecting to everybody and all the services that were happening around us. The way we consumed services and products, that itself fundamentally changed. By 2015, there were a large number of apps that was driving the internet economy. Right. And these apps went beyond, they started coming up everywhere. And if you look at apps like a Zomato, like a Swiggy, like a Oyo, like a Ola, right? These are homegrown, companies in India. But, these companies really started from nowhere. If I look at a Facebook today, it's grown in valuation significantly, but at its heart, it started out of a dorm room. So many of these apps suddenly the availability of the phone and the access to the internet through these mobile platforms gave us the mechanism, the means to be able to reach out to a very large audience with a very limited resources, right? It allowed us to scale up. It did not need a large computing infrastructure to start off with. So you did not need all the capital investments, and this led to new ideas floating up in the economy, and those ideas getting rewarded by becoming large organizations in their own right. So that's the new kind of employment that is getting generated, right? Very operations driven apps, but it no longer takes an established company to come up with a new product anymore. That's the fundamental change. And in the process, what has happened is the number of computing devices that you can see have been growing up exponentially, has been growing very fast, because now it is no longer, I have a desktop. I mean, most people will not have a desktop today, but look at the sheer number of computing devices that are all around us. Right. I definitely have a couple of laptops. There are 3 or 4 phones in every household. There are multiple smart lights, smart wearables. So our context is getting distributed in all these systems around us, and that is where fundamentally all things which were disconnected started coming on board this next generation of internet revolution, or what we call as the Internet of Things, right? And this is where we see devices which had no connectivity getting connected, devices which were purely electrical, for example, a street light which used to run on an AC power supply and was operating on the very simplistic principle of resistance producing heat and causing a filament to glow. Right? From that stage, now we are using electronic devices. We are using light emitting diodes there. And not only that, we are trying to control the amount of light. We are trying to control the light so that it switches on only when the weather conditions call for it to be switched on. We are looking for lights which switch on only when somebody is walking by. Somebody needs that light, right? So it's becoming need dependent rather than just our ability to switch on the light. And that is what has been driving the Internet of Things for the past few years. And you see how an electrical device now becomes electronic, now has power conditioning circuitry on it, now has electronic components on it, now has communication that is on that device itself, right? And these devices, the fact that these devices are becoming smart is evidence that we will continue to witness this kind of digital enablement going forward. The state has also taken cognizance of it, because of which you see that the smart city initiatives are there, which means that the state feels if you can sensorize the urban areas, the environment around you, you will be able to collect enough information from these sensors to provide tangible value to the citizens of the place, right? To the people who are there around. This includes solutions like smart parking, smart traffic lights, smart waste collection, smart transportation, right? Which basically, the word "smart" here is a replacement for saying I get information from these systems on a real-time basis or on a near real-time basis, right? So I don't have to waste time waiting for a bus at the bus stop when I can actually spend the time more usefully and go to the bus stop only when the bus is there, right? So that is cutting down on the dead time and converting that time into something that is more productive, right? At the end of the day, we all want to be in a place where we are doing the things that we want to do, rather than being stuck up in doing things that are not of value either to us or anybody else around us. So that's where we are. We are becoming more and more of a cashless digital city ecosystem, and that has its own pros and cons. That has its own benefits. It has its own advantages and disadvantages. But this is the fact of life that we are moving ahead with, and more people will start using these services, and they will start using these services, each of these services more and more. Because of which we need large IT infrastructures to manage this exponential increase in digital interactions that are being caused due to increased penetration and depth of usage. Right. To illustrate this point, I have a video.
Everyone wants their city to be safe, digitally savvy, and technologically accessible. That's why it's critical for cities to invest in infrastructure that makes smart living possible and sustainable. A smart city leverages digital technology to connect, protect, and enhance the lives of residents. The Internet of Things, or IoT, acts as a nervous system with sensors, video cameras, social media, and other inputs, providing the city operator and community with constant data and feedback so they can make better decisions. From smart lighting that helps keep city lights on, to digital crime fighting using facial recognition, to intelligent transportation and beyond, cities are clearly poised for modernization upgrades to become smart. These technology-driven solutions are redefining the business of running a city and have equal influence on how cities generate revenue, as well as how they own and manage assets. In fact, the potential benefits of digital transformation in cities are huge. Digital cities can generate $2.3 trillion globally through 2024. The deployment of these innovative new technologies can even provide a single pane of glass view of all of the community's data and cross-domain intelligence. This includes the capability to collect, aggregate, and refine data, then distribute it for faster response, improved decision-making, and more informed long-term planning efforts.
Right. That video is pretty self-explanatory, but there are quite a few interesting points that come out in that video. Come up and operate these systems. They're going to build the hardware. They're going to build the smart hardware, which has the traditional functionalities, like I mentioned, of a street light, and convert this into a smart device with the power conditioning, the sensor integration, the compute, and the communication. Right. So there's going to be a need for a number of embedded engineers to kind of work on those projects. Then once those sensors are built out, we would have a large requirement for field engineers who would go out and install these devices. They would go in and install these devices. They would configure these devices. They would commission the service, right? So there is a requirement for a large workforce to do this work. The third piece of work is when you look at this smart cities. At some point, all this data is coming into a command and control center. And the command and control center needs to visualize the data that is coming in from all these different sensors, from all these different data points, right? So that tool or that visualization engine, those command and control softwares, right, is where IT and information technology will help significantly to build those applications as well as to monitor and diagnose those applications, right? So there is opportunity for embedded engineering. There is opportunity for product development and product design, for product deployment, for IT systems, for command and control operators as well. Those are the next generation of opportunities that are coming in the market over the next it's already started, but it's going to grow exponentially over the next 5 years time frame. And that is important for us to remember, because we are educating, we are graduating a number of students. We have to ensure that they are trained right to take advantage of those opportunities. India has been developing its own technology stack so that the next generation of applications can be built on top of that. Right. There are a number of applications over here. I don't know if you have heard of this application called API Setu. I'll come to this in a little bit. There's of course digital identity systems that we have built, large scale biometrics databases, Aadhaar in this case, right? There is a cashless system that we have brought out. It is governed by the RBI, so it's a unified payment interface, and that has reduced the flow of actual cash within the economy and the need to keep on printing new cash, right? Then there is the entire taxation system, including something called as the GST network. The Goods and Services Tax Network allows payments to be made electronically when an invoice is generated. Right? That's a major step because it has created a fluid ecosystem within the entire country, allowing it to work as a large economic bloc. The fourth thing is called eMudra or eKYC. This is a digital certification system that we have, and today most high-value tenders, high-value income tax returns require a digital certificate of the people, of the directors or the primary stakeholders. So this is another major system to guarantee the authenticity and of people signing off on documents. It brings about a lot of traceability within the system. We have been debating a lot on building a blockchain system, and the first versions of Niti Aayog's thought paper on blockchain is already out in terms of what the India strategy should be. We are also looking at a lot of adoption of blockchain, even for IoT-based solutions, where we are looking at reducing the overall. We're trying to use blockchain as a transaction management system for the entire IoT network, so that records cannot be overwritten, right? And finally, this is very important, that India has been developing its own API gateway for all the e-governance projects that it has been doing, and this allows the public to the public as well as private entities to come on board, work with the government in building IT systems that are going to be of relevance to the current society. And the API Setu is a centrally managed API gateway. All the publicly accessible APIs from the government portals are listed here. In fact, I was looking at it a couple of days ago. They have the entire CoWIN APIs available as public and protected APIs available on the government website, and this allows pretty much anybody to go ahead and build a vaccination app or build a vaccination system in probably less than an hour, right? If you look at these APIs, these are very simple APIs. You have some metadata APIs, you have some availability APIs, and you have some authentication APIs. So if you were to use this system and build your own vaccination app, it is probably going to take you probably an hour to build this whole thing. All that you need to do is get some appointment availability by querying this calendar by districts. If you know your district, you can or you can go start off with looking for districts, find your right district. You can look up the calendar by districts. It will give you the availability status of vaccines. If you are getting an availability, then you need to authenticate yourself. Right? You can go generate an OTP, send back the SHA-56 value of the OTP along with the transaction ID that was generated over here. They will go into this function, into this post function, and you will get a token, access token. You use that access token and you can look up the beneficiaries which were listed with that particular phone number. If you get the beneficiary, then you can go ahead and make a appointment schedule in that particular center ID along with your authentication token. So that's probably about 5 or 6 interfaces that you need to integrate into your system. So that should not be too difficult. This API gateway is published on something called a Swagger platform, and if you go into this website, you can look into all the error codes that are there. You can look into the way the data is sent. So you have the metadata information, you have the JSON files, all of that information is available, right? And if you have that information available, if information is published in this manner, then integrating these components together into building systems, right? That's what we do as computer engineers, right? It should not be difficult. It should not be difficult at all. And for the students who are over here, strongly encourage, go out, not only the CoWIN apps, look at the kind of other applications that other APIs that are provided from different portals. You have the Vahan portal details that are available, right? So there are a number of different applications that have been published, and you can integrate these into your solution, because today we are as IT, as information technologists, as knowledge workers, the next generation of applications is less about building the application, but more about creating an entire workflow, taking into account various factors that are going to be part of that workflow, right? It may involve a few IoT devices, it may involve a few human aspects, it may involve a few third-party integrations, and it may involve a few proprietary code to be developed. But the integration is where that value is today. IoT is something that is very, very context aware. I brought up this point earlier when I said that with IoT, it is no longer, it is the user context that moves around, and that becomes very important, right? It becomes an integration of systems, right? So when I look at something, at even a simple question of switching on a smart bulb, right? Switching on a smart bulb here means that if I ask for my bulb to be switched on, it should switch on, right? But in order to enable this infrastructure, there are multiple pieces in this puzzle that needs to be created, right? It's the end goal looks very simple, but the overall architecture may involve several parts and components. So in order for us to use this smart bulb, we need a mechanism, we need a commissioning mechanism to tell the bulb that, hey, you are behind a firewall, you need to go and tell your device cloud what is your IP address, because the device cloud does not know your IP address, because your IP address is being provided by the DHCP running on a local router. Right, so this reverse communication has to be set up. This is called as the server inversion problem in the Internet of Things. I'll come to it later on. But for the time being, I have to connect it over an out-of-band channel, like a Bluetooth channel, and essentially write to the bulb that the SSID and the password for my router is so and so. Once I do that, the bulb can now communicate to its device cloud and register itself, right? So there's a new process that comes in of registering with the device cloud. Now, once that is registered and it is working, the next aspect comes with respect to just asking, Alexa, switch on the lights, right? This is a smart smart conversational platform. So these platforms, and there are equivalents of not only Alexa, but there is Siri, there is Google Home, there's a bunch of different options now. There's Cortana from Microsoft, in case we forgot about that. So these have essentially just the right amount of hardware to keep on looking for this word Alexa. It does not do anything much beyond it, right? It does not have a large NLP engine running in the smart speaker itself, because it would make the cost of the smart speaker prohibitively high, right? So when it hears the word Alexa, which is its wake word, it records the rest of the packet, just records it, and sends over this recording to the conversational platform, right, the backend platform, wherein it says that, hey, I got this packet. This is where the first step of magic happens, really, and where all the natural language processing algorithms that we have been building up, right, are used to take away the accent from that voice packet. It is all the mother tongue influences that we have, those are removed, and that voice packet is converted into a text, right, of saying switch on lights, right? Now we know, now we have something actionable because it says switch on lights. So there are two references to, there is a verb over here which is switch on, so some action to be done, and there is a subject to this, right, which is lights, right? We don't know what any of these mean. So we look up the user profile next. We look up the user profile and say who has asked for these lights to be switched on, right? Somebody has asked, Atanu has asked for these lights to be switched on. Okay, what does Atanu's lights mean? What are these devices which we are referring to by calling them Atanu's lights? So I can look up this profile and look up this table over here and say, hey, Atanu has a light by some device ID ABCD, or whatever hex code that may be in. So once I know the light ID, I can now look up who is the provider of this light, who can tell me what to do with this function switch on, right? Because clearly this conversational platform just understands language. It does not know how to switch on a light. Right? So it is going to look for this device skill resolution and find a mapping between the device ID and the vendor for that particular device. Supposedly it was manufactured by a Wipro, right? So it's going to look up, what does it take to go and talk to Wipro's cloud, right? It's going to look up that cloud access information. If it needs any credentials, it will authenticate itself and go to Wipro's cloud and say, hey, Mr. Wipro's cloud, I need you to call this skill switch on this device ID, because I have no clue what this device ID means. Now, when you invoke the device, the manufacturer's cloud over here, when you hear this user ID, you look up the user ID, you look up that particular device, and you go, aha, this device has registered with me with a particular IP that is valid right now. So switching on means I need to send it an on command to a particular IP that is currently valid. So that is exactly what it does. It looks up the IP address and sends that IP, sends the on command to that IP address, right? The bulb may go, okay, I've received a command. Its firmware is able to respond to that. It is able to switch on a relay that causes the bulb to switch on, and it is supposed to, it sends back an okay response, right? Yes, the bulb is now in on state, right? This state must be communicated back to the device. Right. Once it comes to the device will say that yes, we got an acknowledgement. So it sends a acknowledgement back to the conversational platform. The conversational platform may convert this acknowledgement into a voice response, which is encode that into a voice packet saying okay, and send over this voice packet to the smart speaker, which plays this back, right? And you hear okay, lights have been switched on. So from you asking for the lights to be switched on, this light comes on in probably a matter of a second or so, right? But in the meanwhile, there are over here I have about 14 steps. Typically it may be 20, 30, 35, I don't know. It's a very large number of intermediate steps that were processed in order for this functionality to be achieved, right? And that's where IoT comes in. It's an interoperability of all these systems which are in different places. These couple of clouds could have been, this could have been in North America, this could have been in Bangalore, this could have been in Kolkata, right? Who knows where these devices are? But these devices are, these disparate systems are able to communicate between themselves and provide a service that is usable, right? That is reliable, right? Those are essentially what we are looking from this entire service, right? So what is happening is with IoT, these kind of complex workflows are being enabled, right? Here we have an example of a light, but in a number of cases, the input comes from sensory devices. The input could come from a weather sensor, and you could be switching on the light based on a weather sensor, or you could be switching on the light based on a particular schedule, or you could be switching on the light based on some other parameters that are being fulfilled, right? But with these platforms, these are decoupled systems, and which is why they are able to work independent of each other, yet working together to solve a common goal, right? The next generation of applications are going to be beyond the library management systems. They are going to be beyond the shopping cart systems or workflows that we are familiar with. The next generation of systems are going to have integrated sensors in the shopping cart with seamless cashless mechanisms that are built in, so that you can just buy the things that you want and walk out, and the system will kind of identify and bill you accordingly. Right. With IoT systems, there's a lot of connected information because there is a plethora of sensors. It is not one or two sensors. We already saw that with IoT systems, things are connected at scale, right? When they are connected at scale, it means there's a lot of different kinds of information that are coming about. The input set is very, very heterogeneous. It could involve, sensor data coming in from, say, electric meters, which need to be read once a month, to video cameras, which are high definition video cameras, which are just pumping out data like anything, right? So there is a wide spectrum of data usage of the streams that are coming in, and there's a spectrum of velocity of data that comes in. Some devices are going to, accelerometers, for example. If you're trying to measure seismic activity, the data rates are very, very high. There's a lot of data points coming in very, very quickly. The velocity is very high, whereas something like a video camera gives you a very high volume of data, right? So when you bring them all together, you get this kind of
command and
apps.
control, delivering operational Internet of Things, connecting endless numbers of sensors and procedures in a logical way. Modern security and operational threats come in all sizes and shapes, and the definition of site management is in constant change. Staying ahead of challenges requires ingenuity, adaptation to threats, and know-how. Ensura Command and Control Limited, providing advanced visualization, connecting all cameras together into one intelligent mesh. Develops off-the-shelf operative CNC systems that intelligently combine unlimited sensors, flexible procedure implementation, and target acquisition through clear and easy data delivery to the user. Our Ensura VMS and Ensura PSIM systems constitute a total management solution for tactical systems with a suite of operational video, multi-sensor, and organizational management features. Our total security, operational, and smart management solution fits deployments of all types and sizes, from gas stations to hotels, prisons, smart cities, and more. Our solution acquires targets using a smart BI rule engine, clear map display with location-specific videos and sensors, object tracking, advanced video analysis, an intelligence layer that enables complex rule implementation, and custom screens defined by the organization. Ensura VMS and Ensura PSIM are open systems that effortlessly integrate various sensors and video streams, support multiple entities, and provide unlimited flexibility. They are easy to use and support any level of operator in any language. Furthermore, they are fully scalable, allowing unlimited expansion at both the sensor and the user levels. At present, Ensura VMS manages over 12,000 cameras and 15,000 sensors worldwide. Ensura Command and Control are based on profound security know-how, both human and technological. Our solution is stable, with a proven track record of complex installations, and is designed to answer your real needs. Ensura Command and Control, delivering operational Internet of Things.
So the reason I brought up that ad is it gives you a feel of what this next generation of command and control centers, of this command and control applications are going to look like, because you have to be able to visualize data that may be coming in from typically 50,000, 100,000, maybe a million devices all at once, right? And the kind of traditional workflows that we have seen with even with ERP systems or consumer applications, right? They cannot handle this kind of complexity. Typically, the display is not on us. That application is no longer displayed on a single screen anymore. It is typically 6 or 8 screens that is needed to display out all the aspects of the application, right? And these kind of applications are going to become more and more common as time over the next few years. So if we kind of try to look below the hood, below the application in terms of what does this technology mean, and how do you deconstruct a full stack application, a full stack IoT application, right? We'll have to start at probably looking at something that is well understood, right? With IT applications, we build these applications on an MVC model. With M standing for the models or the databases or the stores where the data representation is to be found, right? We have these controllers which are controlling access to the model, telling us what to do with that data. Essentially, we build the application logic by combining the controllers, right? And then there is the view layer, which is the user interface that needs to be built up. I think we kind of what I have observed is our students tend to misrepresent or misunderstand the view layer as being the whole application. But with IT systems, that is certainly not the case, right? Building a good view layer requires its own level of specialization. It requires a lot of the capability to do a lot of user surveys, a lot of user feedback, and do a lot of research there in order to understand what is the usability of the view layer. But having said that, simplistic view layers are not very hard to build, and there are lots of tools that are available for it. What's different for IoT applications, though? Right? First of all, a lot of the data comes in from the field devices. That is very, very important, right? And these are different kinds of field devices. There are edge devices or edge gateways, and edge gateways typically have a significant computing infrastructure on them. So they can be expected to be connected over leased lines, over Ethernet networks, and can deliver a lot of data, pretty stable connectivity. Right. There is data that comes from field gateways, and multiple field gateways can come and integrate with an edge gateway. Typically, the field gateways are wireless. They may be able to talk IP. They may be able to talk over cellular connectivity. But in most cases, field gateways have a limited range, and they typically talk with edge gateway over non-standard protocols, non-HTTP protocols. And for the IoT devices, which are typically battery operated, we cannot even, I don't think we can consider them to be capable of running a full internet stack, right? So they need a very specialized IoT communication stack, and the IoT equivalent of an OSI model to run over there. Plus, we have simulators. If you're building IoT for applications, we always need to build simulators, which would at least be able to simulate the kind of traffic that we expect out of it, right? So that's one side of it, right? We have all these different kinds of devices that needs to be taken into account. The other aspect of it are the viewers, right? What kind of systems will be used to view the information? And they are not very different. You have your standard mobile phones, your desktop applications, reports that needs to be generated. These are pretty standard viewing platforms. But with IoT, there are a few new ones, including kiosks, including ruggedized tablets, human-machine interfaces. So there are a few more different kinds or different form factors of devices that are used, which are typically acting on a thin client mode, right? Which means that there is a browser over there, and it's just going to display, the web portal in full screen, right? So the applications, the viewers themselves are usually not very smart. Most of the work is done in the application itself, right? If I look into this a little bit more deeply, let me go into what the models are. And typically, when we look at a model, we look at the kind of databases that may be used to store the data representation. That's where a lot of things have changed of late, right? we use structured data. We have seen the use of a structured data with MySQL and PostgreSQL. These are pretty popular stores for structured data, where we know about what kind of data that is going to be. What is becoming more popular nowadays is MongoDB, which is an unstructured database. And with Mongo, instead of keeping a data record, we keep a document containing the record, right? So which means if my document changes, or it frequently kind of changes, or the representation of my information changes, it is relatively easier to use a non-SQL database like MongoDB. But at the same time, when the volume grows, it is, the Mongo does not give us that ability to have an indexing system. So for very large databases, there are issues with Mongo there, right? Having said that, MySQL, PostgreSQL, most of them, they cannot scale up to a multi-nodal model, right? So if you want to scale up an SQL database, you just need a bigger database. That's about it, right? You cannot build redundancy or build auto scaling into the system, right? The third thing that I have here is called Apache Cassandra. And Cassandra becomes very important when you are looking at time series data, as would be the case that you expect from a lot of these IoT sensors, right? The representation, the actual data representation on the disk from Cassandra is slightly different from Mongo, because you want to keep items that are grouped by a device and into logical blocks of time, essentially, right? Slightly different access to it. You can also use, in a lot of cases with IoT applications, you don't want to be working on streaming data that is coming into you, but you may want to pre-compute a lot of that data, save the data in different forms, or pre-compute an image from that data and store it somewhere. So whenever you are using that form of mechanism, that form of access to the data, you can use something like an Amazon S3 storage system, or even a Glacier system if you want to go ahead and do that. Then there are a couple of more interesting platforms, Apache Spark and Firebase. With Spark, it allows you to manage streaming data much more. It allows you to create multiple streams from your incoming stream and pass on each stream to different portions or different parts of your application, right? So that you can evaluate different rules or different models concurrently and arrive at a conclusion faster. Google provides Firebase, which is a database as a service. So if you are not building your own controllers, Firebase comes built with inbuilt controllers for doing a lot of the insert and CRUD operations on it. Right. Now that's on the model side. So with IoT applications, you now have a number of different database choices to act as your backend model, right? On the controller side, again, when we all started, pretty much the only option was Apache and PHP, right? But over time, we have a lot of different environments that have come up. There's Python, Rails, and Node.js, which are very, very popular platforms. It's good to build on them. If you are looking at building the web framework on front of it, then Python has its own internal frameworks. Node has Express.js. Ruby on Rails has its own framework to kind of work with, right? Each of these have, depending on where you are, how fast you want your application to be built, or the kind of control you want over your system, any one of them are good choices to go ahead with, right? And for the viewing layer, you can build, pretty much on HTML and JavaScript, right? Use a bootstrap system that will give you responsive UIs, because if you're not sure about the kind of end device the system is going to render on. Plus, you have different engines over here. You have a React library. You have you can use AngularJS or Angular 5. You can use Vue, Vue.js. So three very popular platforms. Depends completely on your comfort level in terms of building applications with on top of that, and based on which sequence of or which combination of technologies you pick, you pick up on, right? You have different kinds of full stack, right? You have a lamp stack, which was typically the lamp or a WAMP stack, which we were using when we were building probably library management systems 25 years ago, and those systems typically had an SQL backend, Linux or a Windows environment, an Apache web server, and a PHP based system, right? So those were the older generation systems. Current generation systems are using more and more of Mongo as the backend. They are using Node and Express as the intermediate, as the computing infrastructure, and then again either Angular or React, depending on whether you are a mean specialist or a MERN specialist, right? Ruby on Rails gives you absolute control. Large good websites like even GitHub are built on Ruby on Rails, so very good platforms to build the whole things on. Or if you don't want to build all of this, you can still go to a WordPress, and there are enough customizable modules to build a website on top of that, right? So that's my take on the updated MVC principle for IoT applications. The data sets are different. The kinds of devices are different. What is interesting here is these edge gateways are capable of running a Python environment. They are capable of running a Node environment. So you might be able to build an entire application, right, on the edge gateways themselves, right, which allow you to build an interface so that, just like your router, your home router, you can configure your home router, by logging into it from your phone. Right, you can create this kind of configuration and control applications on the gateways themselves. Right, that's one interesting area of usage. Right. Now, in terms of functionalities, there's quite some change that has happened. When we build IoT applications, we look at several functional modules within it. There is the device management part of it. There is the data management part of it. Of course, we definitely need dashboards. We need an integration platform. We need a billing and charging system, and we need these user management systems, right? One thing you will notice that in terms of roles, there are multiple roles that are going to use these systems. They're going to, of course, going to be system administrators, customers, operators, executives. What is interesting is that even devices are your users, because devices will log into your system. You need to have authorized usage, which device is actually allowed to work with your system. That is essentially a user management problem. So a device is also a role in this entire application, right? Digging into it a little bit more, the user management and the dashboarding features, these are already found in traditional ERP systems, in traditional IT infrastructure, right? So nothing very interesting to explain over here. With the user management, you need some kind of a database to understand what are the different, the list, essentially to kind of list out your users, and you need to understand what your roles are, right? You need to define your roles, right? That's why when users log in, you need to build some login screens and have a session management system in place, right? So that somebody is not logged in for eternity, because somebody, if you do not manage your sessions, you will run out of resources in order to serve more needy users, right? With role management, you need the ability to do CRUD operations on them, which means you must be able to make a role, delete a role, update a role, right? That needs to be done. And then you need to be able to map between users and roles, right? So that's role assignment. These are systems that are well understood, right? This is there, whether you build a simple workflow, wherever you're using a user, you have whether you're logging into your, say, to pay your phone bills or to any portal, you will find some form of a user management system in there. The dashboards are important. in IT systems, in typical IT systems, we have seen, the dashboards are of different types. They do not always show real-time traffic, real-time information. But with IoT dashboards, there needs to be a lot more visualization. There's a lot of different kinds of scales that are there. With the COVID pandemic, many of you may have used the COVID-19 app, which gives you a dashboard of how the cases are progressing on a day-to-day basis. It gets updated on a daily basis. But think of that, that system on super steroids, right? Where you have a lot more data coming in from a lot of different sources. With the COVID-19 app, the data is manually fed in, and that's how the dashboard is updated. But here you have a lot more transactional data that is coming in. Data could be generated at millions of data points per second, right? Which is why it is very different. And with the dashboard, you need a widget management system. Who wants to see what view, right? You need to have a reporting engine. What happens, what are the kind of reports that you want to make? What are the kind of fields that needs to be populated in each report? You don't want it to be hard coded. You want it to be a flexible system so that a user can compose the fields they want in a particular report, right? So that's where the reporting engine and the reporting engine customization is going to come in. With data visualization, you need the mechanism to be able to slice and dice data, which means you should be able to search for a particular range of data, whatever the range conditions are, whether it is time-based or event-based or whatever they may be. And you need to be able to slice it, which means that if you are looking at a certain section of the data, you should be able to expand on that. You should be able to get an expanded view, or you should be able to narrow down on a particular area of interest. That's what we mean by slicing and dicing that data, right? So these are traditional workflows. We understand them. I'm not going to spend too much time on them, right? The second part is the integration servers, and just like I showed you with the API gateway, many of the popular services, when you build an IoT system, you are going to see, you're going to need multiple services. You may need a location service, or you may need to have a payment integrated with the IoT service, right? You have to make a payment before you can use the service, right? So you will find a number of different vendors or different services that are already out there. They have, they will provide you with the developer API so that you can integrate their systems, their data with your application. Whether it is you get your location from MapMyIndia or Google, completely up to you. Whether you're going to use a notification service like Amazon SNS, or you're going to go with a proprietary Vodafone to send out your SMSs, completely up to you. But there are quite a few of this third-party integration systems that are available. So when you build a system, you must identify what are these integration points, and if you need to have clarity that you have access to the data the way you want it, and that is why you need to be able to understand and read those APIs. These APIs are simple documents. It tells you how to access a particular resource, and it tells you how the resource is going to come to you. So the interface and the data format, these are the two important things that are needed to access those systems, right? We are running a little short on time, so I'm going to speed up a little bit. Earlier, I had referred to the server role reversal when I mentioned about the smart bulb, and what happens here is because the bulb is switched on behind a firewall or behind a router, it gets an IP address that is not public, that is not globally unique, right? Now, typically, when we use systems, mobile apps or any other application, the server address is well known and public. We put up a website, say www.ndtv.com, and that will resolve to a known IP address, right? Which is how I access that website. Unfortunately, with IoT, it is the cloud system which wants to access the gateway, and the gateway has a dynamic IP. So that's the problem. That's the big problem, because unless the device tells the infrastructure where it is, there is no way for the infrastructure to know. So there are some solutions around it. There are solutions to have local only access. You can build that, or you can have a bootstrap server. Some mechanisms are allowed. Some protocols allow you to have bootstrapped access, right? And then there are secure access channels using other publish subscribe protocols like MQTT or constrained application protocol, CoAP, or HTTP long polling, or even WebSockets. So these technologies must be very, very familiar with all of you, right? I don't want to repeat it, but with devices, you need to set up a mechanism so that they can transfer over their data, their state information to you. This is a new area, because device management workflows are what makes this is where IoT applications become a little bit more complex, right? So bootstrapping and registration, every time a new device comes on board, there must be a mechanism to add a new device, right? Just like you say that, I'm going to add a new SIM card, right? I'm going to commission a new SIM card. So there must be screens that allow you to insert some details and say add these details about this device or update details about this device. So there are these screens that needs to support the device CRUD operations, and in the back end there should be a registration process which will take in that information and create an entry in the, what, if you want to call it, a device state database or a product store or a device store, right? Whatever you want to call it, right? But some model has to be created for that. The second thing is device configuration. Once you have a device, what state is it in, right? I need it to be, some ports to be set at some IP addresses, or I want an actual sensory data to go over to a field device and switch on an action, right? So that is a configuration. And this configuration, there has to be a screen from which a configuration can be given, or an API which will allow this device state to be updated and reflected to the edge gateway, moved over to the field gateway, moved over to the device, and the acknowledgement has to come back all this way and reflected in the UI, right? So that's a significantly more complex workflow, because it involves many more components, right? The more components, the more chances of failure. Hence, building and testing these end-to-end workflows are challenging and presents the next frontier of work. Similarly, there is firmware lifecycle management. So, today your mobile apps, you can get a notification saying that, hey, an update is available. But with these end devices, which are not always powered on, firmware management is very, very difficult. It has to be a complex coordinated process, and typically firmware management systems, these are large systems by themselves, where you can have different firmwares that have to be uploaded into different devices, so you need a firmware DB. When you update the firmware, it means different things, right? When it's a small IoT device, there may not be a complete application space. So the entire application and the OS gets bundled together into a complete firmware, and the whole firmware needs to be changed. So you can have something like that, or it is just the operating system remains the same, but an app on it changes, or just a configuration on that app changes, right? Or a parameter or a file on that app changes. So the firmware management is a complex process by itself, and it needs to be scheduled, especially when you are looking at millions and millions of devices. You cannot have a system outage all over. So you need to build out the system so that only a few are being updated, or it has been updated based on a certain time zone or some other attribute. That is why the updates cannot be done very all at once. It is going to completely jam your network, right? You have to have better mechanisms to do that, right? Similarly, with troubleshooting, you need to be able to do that. This is another workflow, because when the systems get stuck, you need a mechanism to do a firmware, do a remote reset or a remote restart, so that the device can kind of come back up on, or you can put it into a diagnostic mode, get access to a few more parameters which are not available to the end users, right? So troubleshooting mechanisms need a UI which have with those APIs exposed, so that a control can pass on to the end devices. So device management is a complex system. There are companies that specialize in device management systems with mobile phones. The equivalent is called an MDM system, or a mobile device management system, and typically they kind of control the policies that are there on all mobile phones that are used in a corporate environment, right? With IoT device management, a similar thing is coming into the picture. There are some standards like lightweight M2M, which are being enforced to do some of this backend communication between the controller and the end devices. And there is a strong demand for people with good experience in these standards. Similar to device management, you have to understand that in an IoT system, when data comes in, there is high volume of data, there's high velocity of data, and it's essentially a very heterogeneous system. So when that data comes in, there needs to be a system in place that is going to distribute that data before it gets used and destroyed. Right. So some of the data is going to be noise, so you may not want to store all that data. Some of the data is going to be actionable. So some of the data is going to go into databases. Some of the data is going to go into rule engines. Some of the data is going to go directly into time series databases, and some of it may go into storage. Right. So the data management workflows are designed to as configuration workflows that allow you to tell what to do with the data. This is also the place that you hook on to if you are building machine learning algorithms, right? What kind of data is going to come in? You have ETL screens, you have execute, transform, load screens, where you kind of pull in the data, clean it up, and then you start your machine learning process on top of it. Right. This is also something I would not say that this is new for IoT, but given the diversity of data sources that you deal with in an IoT system, this has an elevated position for IoT applications. Right. And finally, the last application I wanted to, or workflow I wanted to talk about, was the billing and charging workflow, because at the end of the day, you are doing this whole IoT, you're deploying this whole IoT system, because at some point, somebody's got to pay for it. So usually it is somebody, if a city is building it, they may want to pay for it upfront, and you build a system for them. But in most cases, the IoT systems are going to be built like mobile phones, right? You're going to be on a plan. And if you're on a plan, then, just like you use a mobile phone, you need to have your service commissioned, right? It's not about the physical connectivity, but the service connectivity. And the service connectivity happens when you are being built for it. Then there's something called a CDR management, or a chargeable data record management. What is it that you are going to be charged for? Right? What is the service? So if you say that 10 messages per day is messages are going to be chargeable units, or number of push requests are going to be chargeable units. What in your system is the chargeable unit, right? Because once you define that, only then can you start charging, right? And the next thing is the billing plan, right? In your plan, how many of those units are allowed at what price point? So you have to be able to reduce your usage to a tangible bill, to a final number that you need to pay, right? And finally, the customer management, sending them the bill, sending them the invoices, consolidated statements of records, right? All of those are expected to be there. New generation of applications, because if you think about an e-commerce platform where you basically have a price associated with an object, right? So that is pretty well understood, and it is a product, and per product there is a price that comes from the inventory management system. But with an IoT system, the system is in flux, which means that you are going to, each operation is going to use different systems, different, for example, if I have to get an alert message from the sensors, it might require not only the sensors, it might require, a lot of battery on those sensors and the intermediate devices. It might become very expensive for me to acquire that piece of information. which is why the costing model must take into account all the minute pieces that were used, how many APIs were used, how many data insertions were made, how many data extractions were made, how many messages were sent on the communication network, right? All of these things have to be taken into account to create a chargeable data unit, right? That's why it is a little bit more complex, right? But again, it's not one system. I'm just breaking it up. This is not an exhaustive list. It is just to kind of give you all a sense of where the next generation of applications are going to be built, and the kind of functionalities that are expected from those applications, right? Not exhaustive by any means, right? And these are just the functional parts of it, right? Apart from this, when you build IoT systems, you have to take into account the non-functional requirements as well, because if you are not matching the non-functional requirements, functionality is not going to help you. IoT systems are very, very latency sensitive. They a lot of these consumer applications, like switching on the light bulb, it is the experience of the customer of switching on that light using voice, right? So that interaction has to be usable, and the user has to go in knowing that the system is secure and private, right? So those interactions, those are what constitute the customer experience, and those are much more valuable than the functional requirements, right? This is kind of interconnected. I'm not saying that these are disconnected, but even on top, it is not about the system just working, but the system working in a responsive, flexible way, right? The transactions, they have to be reliable, scalable, and fast, right? Which means that you have to architect your system such that you can scale up when need be. There is redundancy that is built into the system. There is a hierarchy of service level agreements between various internal services, so that your net transaction can be completed within a predefined time interval, right? Users should not be able to just go in and do anything, right? Their actions should be traceable. There should be compliance of the activities that they are doing with various regulatory bodies, right? And finally, from an architecture perspective, your system has to be flexible. It has to work with other systems. It has to be expandable to include new functionality, and it has to be interoperable with other bodies, because you're interfacing data from other systems. Your data is going to go somewhere else, right? So you have to ensure that you are sticking to the standards. You have to publish what your interfaces are, and you have to stick to those interfaces, right? That is why this is where I think the technology interventions are coming in IoT, in terms of developing full stack applications for IoT. I am running short on time, so I will quickly cover what the opportunities are. I think that this is an area that is going to grow very, very fast. At least over the next 5 years, I foresee a growth of almost 30% in IoT services, especially when it looks at this kind of software development services and operations for IoT devices. So I think that there is a lot of scope for full stack developers who are going to come into this space, right? It is a first mover advantage. The market is relatively new, and it's an area where you can grow inorganically with higher visibility. There's a lot of opportunity to do disruptive work, and as a full stack developer, you still kind of preserve your current mainstream opportunities, right? As you graduate, many of you may be in a position where you are either graduated or you are just about to graduate. As you go into the market, you have to ensure that you address the employer's dilemma, right? The employer wants to hire you. The employer is sitting there because they have a requirement. They want to they want you to come in and help them with something or the other, but they are never sure if you are going to deliver on your productivity, if you're going to be interested in the work that he or she may have to give you, or whether you will stick around and make it worthwhile to invest time in building up your skill sets, right? So which is why the employer is always in this two minds when they have to hire a fresh graduate. And I think what is important is for the students to understand that you have to showcase where you are in terms of your skill levels. There, the only reason an employer will hire you is because they expect you to be technically competent at what you are doing. They expect you to be hardworking. They expect you to be flexible and all of that. But the most important reason why they will hire you is because they expect you to be technically competent. And the reason you can become technically competent is to keep on doing more and more and more projects, right? The curriculum is there. The curriculum will help you to understand the basics. It will not get you to the point of having the street smartness, having that ability to the real life experiences of having developed and deployed multiple systems. So you have to think beyond the curriculum. You have to think how you get into doing your projects, how you get into a project based thinking mindset. Projects are planned efforts towards collaboratively achieving acceptance of well-defined scope in finite time. So projects cannot be an everlasting thing. You have to have a very clear goal in terms of what is the project you want to do, by what time you want to finish it, right? If you have that in mind, then you can go ahead and deliver on that project seamlessly, right? So couple of more things for people who are coming into the talk, who have heard my talks before. You know that there's a feedback form, and you can always submit in your feedback. And if you have a project idea that you want me to kind of look at, you can definitely submit that. I will try to give you a project assessment report out of that. And essentially, do not give me very open-ended questions, open-ended answers like you are interested in natural language processing or AI or saving the world. It does not allow me to do a quantitative judgment or a quantitative feedback. If you give me garbage, I will give you back garbage. It's a simple GIGO formula, right? Garbage in, garbage out, right? So when you are thinking about a project, think about, is it something that you can achieve in the time that you want to do it in? Do you have the skills, or do you need to acquire new skills? Is it aligned to your curriculum? Is it focused? Do you want to build something new and something completely innovative? You can, but if you want to build something innovative, which means that you will not have as much guidance. So an R&D project becomes very difficult to close in a finite amount of time. Is it complex or not? Do you know what are the complexities? What are the interfaces that you have to work with? How many pieces are there in your entire project, right? The more pieces you have, it is exponentially hard to test that entire system, right? And testing is the final part. If you are thinking about building a project that you have no way to test, then the project is as good as your word, right? There's no way to verify anything about it, right? Somebody a few days ago told me that they wanted to build this IoT application for targeting and firing guns for DRDO. There is no way you can actually get a gun and test the whole system. So it's a great idea, but how are you going to test it, right? And if you cannot test it, there is nothing to validate that the project actually works, right? So if you give me a good project idea, I will definitely try to come back to you with an evaluation of how well your project is aligned, and if it is feasible for you to go ahead and complete it, right? Or you may want to consider something else, right? That's about it from my side. From the talk perspective, at Capsule Labs, we do a lot of certifications, typically about 250 hours certifications on embedded development, on full stack development, everything with a focus on IoT only, right? So all of the certifications are meant to develop connectivity with the end sensors, right? And we believe in a project-centric approach. We believe in an approach where it's the certificate does not add value unless you try out multiple things, fail at multiple things, and unlearn whatever you have learned to pick up this project mindliness, right? Your project should be able to give you significant amount of value to your potential employer, saying what exactly have you done in your project, what is your standing with respect to the complexity of the project that you have achieved, your schedule adherences, your effort adherences, and your entire project documents. That has to be published, because if you're not publishing that information, your just a certificate is not going to help you much. It's not going to help convince your employer much, right? So that said, you can register. You can just call me up for a registration, or we can discuss that offline. And that's about it from my side, right? With that, I will take questions. Sorry, I went over quite a bit.
No, sir, it's okay. Thank you, sir, for a nice lecture. Now, the participants, if you have any question, you can directly ask the question to Mr. Roy Chowdhury.
Yes, things have, as a technology, as knowledge workers, what is happening is the more technology we have, the faster we develop new technology. And therefore, there is always this new jargons, this new terms, this new system that keep on coming at you, right? But I think as senior members, we understand what are the underlying principles, or what are the underlying shifts that are happening. What are the various groups that are coming together? Yes, go ahead.
I think, sir, there is no question right now. They already perceived your experience and knowledge very well. So, sir, thank you very much for your such an excellent and informative lecture. As well as I want to thank Mr. Bhaskar Chakraborty and Umesh Pal for giving us the time along with you. I'm pretty sure that participants must have perceived the concept of Internet of Things and its application from the today's session. Now I would request Dr. Shabnam Sengupta, HOD of Department of Information Technology, to present the token of appreciation to Mr. Roy Chowdhury. Sir, can you just please off your presentation?
Oh, I have to switch off presentation. Yes.
Thank you, sir.
Yeah, Mr. Atanu Roy Chowdhury has another role, needs another introduction, that he is an alumni of BP Poddar Institute of Management and Technology, and we are extremely proud of that. And it was an excellent presentation, Atanu, and I'm sure the participants will be immensely benefited from it. And we will definitely get in touch with you for the next steps, for the next events that we can plan in future. And it's my privilege and honor to present the e-certificate on behalf of Department of Information Technology of our institute. Please accept it.
Thank you, madam. Also want to mention I have Umesh Pal here. He's also a graduate of the college from the 2020.
Oh, that's wonderful, and thanks to Mr. Bhaskar and Umesh as well for their time and their contribution. It is definitely appreciated. Thank you so much, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, sir.
Thanks a lot.
Thank you, everybody. Have a very, very good evening.
Yes, sir, just a minute. Now I request our principal, madam, Dr. Professor Shudhabam Mukherjee, to say a few words about the journey of 6 days webinar series organized by the Department of Information Technology. Ma'am, over to you.
I didn't realize madam was here as well.
Thank you, Atanu, for the nice presentation.
You're
Thank
welcome.
you so much for joining us.
You're welcome.
Respected Emeritus Professor B.N. Chatterjee, HODs, today's speaker, faculty and staff members of the Institute, and all the participants. Good evening and welcome to the valedictory session of the webinar series on transformational technologies in recent days, TTRD 2021, organized by the IT department of BP Poddar Institute of Management and Technology. As you all know, that this webinar has been organized during 17th to 22nd May 2021. And as speaker, we had Professor Amlan Chakraborty, Dr. Shubhomay Changdar, Dr. Suparna Bishwas, Dr. Bikramaditya Mondal from academia, Mr. Shandipan Sarkar from industry, and today we had already, Shabnam gave the introduction, we had our own alumni, Atanu Roy Chowdhury and his team. So all of them delivered lectures on AI, ML, blockchain, IoT, and their applications. And today, Atanu especially emphasized on the importance of project-based learning. So I'm sure by attending this webinar, the participants have enriched their knowledge, and many of them surely will pursue their research in these areas. Thanks to all the speakers for accepting our invitation. Thanks to the department, especially the departmental head, Dr. Shabnam Sengupta, and the coordinator, Dr. Geetosri Khan, for nice coordination. Thanks to all the participants for making the program successful. And I'm sure in future also the department will organize these types of programs to expand the knowledge beyond the curricular boundary. Thank you.
Thank you, ma'am, for your inspirational words. Now I would request the coordinator of the webinar series, Dr. Geetosri Khan, to give the vote of thanks in this valedictory session. And before that, I would request all the participants to turn on their cameras for the last group photo. Ma'am, over to you.
Thank you, Shubhadeep. Am I audible? Everyone?
Yes, ma'am, you are audible.
Okay. Thank you for giving me an opportunity to give vote of thanks in this 6 days webinar series organized by Department of Information Technology of BP Poddar Institute of Management and Technology. This webinar has started from 17 May to till 22nd May through the virtual platform. And I think this webinar series must have provided you a forum for sharing insights, experiences, and interactions on various facets of evolving technologies and patterns of recent days. Being a coordinator of this event, at first, I'd like to thank on behalf of the organizing team to our chairman, Sri Arun Poddar, our vice chairman, Sri Ayush Poddar, our founder, trustee, and chief mentor, Dr. Shubhit Chowdhury, Principal Ma'am, Professor Dr. Shutapa Mukherjee, our respected emeritus professor and former Dean Academic Professor B.N. Chatterjee, Register Dr. Shubhashish Pradhan, our head of the department, Dr. Shabnam Sengupta, our senior adjunct professor, Dr. Dipankar Sharkar, for keeping trust and support us in every possible way in arranging this webinar series. Without them, it could not have been possible to organize such a webinar in a bigger dimension where more than 200 participants registered and more than 40 plus colleges have participated in this event. Our main focus of this webinar is to imparting knowledge on the fundamentals of interdisciplinary field of convergence of artificial intelligence, machine learning, blockchain, and IoT in recent days. Hope all our esteemed participants are familiar and perceive with the concept of emerging field of IT approaches for transformational computing, both at research and application level. I hope this course will be beneficial to our faculty members, research scholars, and students who intend to practice or begin the research in the field of information technology. My sincere thanks to all the esteemed speakers, Dr. Omlan Chakraborty, Professor and Director of AKCSIT, University of Calcutta, Dr. Shubhamay Chowdhury, Assistant Professor of NIT Durgapur, Dr. Subarna Biswas, Associate Professor of Macau, West Bengal, Mr. Sandipan Sharkar from IBM Kolkata, Dr. Vikramaditya Mondal, Associate Professor of BPPIMT Kolkata, Mr. Atanu Roy Chowdhury, Founder of Capsule Labs, for their wonderful lecture, without whom it could not have been possible for making this webinar so enriching and interesting. I am extremely thankful to all the students and faculty members of the organizing team who have worked hard tremendously day and night for making this webinar a grand success. My sincere thanks to all the esteemed participants present over here from different national and international reputed institutes, without whom this webinar could not take such a shape. Thank you once again, everyone, for participating in this webinar series.
Thank you, ma'am. Thank you all for your participation in the 6 days webinar series. We know we all are crossing over a very tough time at present. Hope we will overcome it very soon and will start our normal life. Thank you once again. With this note, I'd like to conclude today's session. Thank you. Feedback link is already provided in the chat box.